Hello mathematicians, hope after watching this video and getting in a little bit of practice you can say I can factor perfect square trinomials. We're going to look at a few different examples in this video. So we're given x squared plus 6x plus 9. And we're going to see that this is going to fit into kind of a pattern called the perfect square trinomial. So both the first and last term have perfect squares, and we could factor out a 2 in this middle term. So we could rewrite this as a quantity of x squared plus 2 times the quantity of 3x plus the quantity of 3 squared. So we're going to pause this and we're going to go off to the side and just talk about something, and we'll see this pattern kind of start to develop here. So if we're talking just x plus c squared, well, we know that this is equal to the quantity of x plus c times the quantity of x plus c. And if we were to go and FOIL this out, what we would see is we would get, well, x times x, that gives us x squared, and then x times c, that would give us plus cx. And c times x again, that would be cx or xc, so plus cx. And c times c would give us plus c squared. So now if we were to go to and combine our like terms in the middle, this would give us, this is equal to x squared plus 2cx, because there's two cx terms, these are both like terms, with a coefficient of 1 more or less, and plus c squared. So we see if we were to FOIL this binomial out that's being squared, we'd get x squared plus 2cx plus c squared, which is similar to what we have going on over here. So if we see that this right here, so what would be our x in this problem? Our x would just be x, so that's the same. And what would be our c? Well, our c would be 3. So this binomial right here, if we were to factor out as a perfect square trinomial, would be equal to x plus 3 squared. And we can go ahead and let's rewrite this as two binomials being multiplied by each other just to prove that this is factored out correctly. So we get x times x, that'd be x squared, plus x times 3, so plus 3x, plus 3x, plus 9. And that would give us x squared plus 6x, minor like terms there, plus 9, which is the original binomial we started with. So this right here is factored out as a perfect square. Let's look at another example and kind of just go straight to the process. So we're given x squared plus 14x plus 49. And we'll see the first and last terms have perfect squares. And the middle term right here is 2 times the product of those perfect squares. So this can be written as the quantity of x squared plus 2 times 7x plus 7 squared. And we see the first and last terms, their perfect squares are x and 7, so if we were to multiply those together, we get 7x, and this middle term is 2 times 7x, so this is a perfect square trinomial. So we actually really do not need to do this step, but I just did it just to show us. So if we wanted to, we could go straight from here. We could plug these numbers or these factors into this kind of formula up here, and we know that this is going to be equal to x plus 7 squared, and that's it. That would be how we would factor this perfect square trinomial. Let's look at one more example that might be a little bit more complex. So we're given 4x squared plus 20x plus 25. And we'll notice both the first and last terms again have perfect squares, and the middle term is a product of 2 times those perfect squares. So this can be rewritten, and again, you do not necessarily need to do this middle step, but I'm going to do it just to show us, make it explicitly clear. So this can be rewritten as 4x squared is equal to the quantity of 2x squared plus 2 times 10x plus the quantity of 5 squared. The first term has a perfect square, the last term has a perfect square, and the middle term is equal to the the perfect square of the first term times the perfect square of the last term. So 5 times 2x would give us 10x, so it is equal to 2 times the product of the perfect squares of the first and last term. So this is a perfect square trinomial. So if we were to recognize this, and again, you do not need to do this step, we can just plug these values into this formula of sorts up here. So this would be equal to the quantity of 2x plus 5, the first term, or the perfect square of the first term plus the perfect square of the last term, squared. And this right here would be our final answer. So that's it for a video. After watching this and getting a little bit of practice, you can say, I can factor perfect square trinomials.